The remainder of our lessons this unit are going to be working with sequences and series, and we have two types that we're going to look at. Today we're going to look at arithmetic sequences and series. And so arithmetic pretty much means that we are adding or subtracting to get the next number in a sequence. A sequence is just a list or a pattern of numbers. And then when we refer to a series, we're actually looking at the sum of all of the values in that sequence. So for example, we have a very famous Fibonacci sequence that has a pattern to it. So like 1, 1, 2, 3, 5, 8. And this is something that we actually call a recursive sequence that we're going to look at in a couple days. But it pretty much is we're just adding the two previous values together to make the next value, but we're adding to make them. So this would be considered an arithmetic sequence. We could also do the sequence 1, 2, 3, 4, 5. You know, what we just think of counting up, but really this is an arithmetic sequence because we are adding 1 to get to each next value. Now, there are several variables that we need to be familiar with and formulas that we're going to use. However, you'll notice there's a note on there that says this is given on the formula sheet. So these formulas are actually part of the SOL Algebra 2 formula sheet. So you're going to be giving these formulas on your test. Most likely you'll have an image that'll be in the direction so you can copy them down on your paper before you get started on the test. So we don't have to have these memorized, even though it might save you a little bit of time. But the big thing is understanding when you can use each one. And so the variables involved, we have n, which is just talking about which term we're at. So for example, if we were talking about the first term, that would be 1 for our n, because it's the first term in the sequence. Our fifth term, n would equal 5. A sub n would just be what term is in that spot. So in the two sequences that I have written up the top, for example, these two would be a sub 2, just the second term in whatever sequence. S sub n is going to be the sum of all of the terms. In other words, the value of the series that's however units long, that n units long. So if I have 5 terms and I wanted to find the sum of the entire, all of the numbers in the sequence, then I would be looking for S5. D is called the common difference, and that's really just the number that we're adding or subtracting to get to the next term. And so if we kind of use this to look at the different formulas we have 3 formulas that we're looking at today. Specifically, we have a sub n, which is just how we can find, you know, what term, what we're trying to find the value of. So if I was trying to find the fifth term, I'd be looking for a sub 5. And then I would plug in a sub 1, aka the first term, plus n minus 1, so what number term minus 1, and multiply that times the d times the difference. So in other words, how many times did I have to add 1 to get to whatever number in the sequence? Our two value versions for s sub n, well, these are the two ways that we could actually solve for the sum of all the numbers in the sequence. So we could find out what the entire sequence is and then just plug all those numbers right in a row into our calculator, but that would take time if we have a really long sequence. And so somebody went through and looked at the patterns over and over again of what we were trying to look for, and they found that we could use either one of these patterns. So the first pattern on there, the n divided by 2 times a1 plus an, well, that's really only going to be helpful if we know the first term and the last term in the sequence. If we only know the first term and how many values we have, as well as the difference, what we're adding to get each one, then that second formula would be a little bit more helpful. And they could be used, you know, just depending on what information you're given. So these are going to make a little bit more sense when we start seeing how these are applied. So first couple problems, let's find the next 4 terms in the sequence. And so we give a little bit of a pattern here to start us out. First thing is, if these are arithmetic sequences, that means we've got to figure out, well, how much are we adding or subtracting to get the next term? So if I look at, well, what's the difference between 16 and 27? So I'm just going to do 27 minus 16, and I get 11. So if I add 11 to 16, I get 27. And if I add 11 to 27, I get 38. So that means my D equals 11. My difference between the terms is 11, and it's positive because I'm adding to get to the next one. And so I could do this kind of the hard way, so to speak. let's see, we have our first term, our second term, our third term. So we need to find fourth, fifth, sixth, and seventh for our next terms. So I'm going to find a sub 4. And let's go ahead and plug that into the formula. So formula said a sub 1 plus n minus 1 times d. So if I plug that in, that means I'm going to have 16 was my first term plus n minus 1, so 4 minus 1, times my d, which is 11. So figuring that out, let's see. I have 16 plus 3 times 11, aka 16 plus 33, which is going to give me 49. Now, that seems like a lot of work to go through to figure out this value. So why don't I just use my common difference? Because if I'm only looking for 4 values, don't have to go the long way around for it. Let's just add 11. So that means our a to the 4 was 49. So our next term, just add 11. So that would be 60. And then a sub 6, add 11, so 71. And then a sub 7 would be 82. Alrighty, number 2. So again, I could approach this with the formula, or I can just find my common difference and go from there. So let's just do that. So 17, I have to go down to 7. So subtracting those, 15 minus 7. See, I'm getting a difference of 8. So that means I have to subtract 8 to get to the next term. And so actually, I do have a little bit of a typo here. That should actually be a -1. That'll be fixed on the copy that you have to download. And so minus 8. So if I keep subtracting 8, then that means my next term is going to be a -9. -9 minus 8 is going to give me a -17. Minus an 8 is going to give me a -25. And minus another 8 is going to give me a -33. Alrighty, so what if they don't give you the values as the pattern? Well, that's numbers 3 and 4. So 3 and 4 says find the first 5 terms of the sequence. And again, we could do this either by, going through the formula. So let's do that at least one time, or we could just use our difference on here. So a sub 2 is going to equal our first term, 12, plus n minus 1. So n on this one is 2, so 2 minus 1 times 5. So we're adding, if we simplify that out, we're adding 1 times 5, we're adding a 5 to get to that next term. So 12 plus 5 is 17, exactly what we would have gotten if we just added 5 to that first term. So a sub 3, add 5, we get 22. A sub 4, add 5, we get 27. A sub 5, add 5, we get 32. Alrighty, go ahead, pause the video and try out number 4. Same thing, you're finding the first 5 numbers of the sequence. Your first term is 6. Your common difference is -2. See what happens. Alrighty, so if all we're doing is subtracting 2 to get to the next term, our 5 numbers in the sequence would be 6 as a sub 1, a sub 2 would be 4, next would be 2, then 0, then -2. Alrighty, so we don't want to go through this every single time if we're asked questions like the next section, where we're asked to find which term or what's the value of a very specific term. And if we have things like our first two, we're looking for the 25th term, and in number 6, we're looking for the 100th term. We're not going to want to add or subtract 100 times to go through and find that. So this is where this equation can still be helpful. So again, full equation that we're working on, let me change my color, is a sub n equals a sub 1 plus n minus 1 times d. And so if they give us our first value, our common difference, and what number term we're looking for, we can figure out what that value is just by plugging in the info that they give us. So if we're looking for a sub 25, again, I know this because n equals 25, they gave that to us. My a sub 1 they gave me was 14. The n is 25, so 25 minus 1, and our common difference here is -6. So 14, I'm going to go ahead and simplify the parentheses first. So 24, and that gets multiplied times -6. So that comes out to 14 minus 144, which gives us -130. So again, I wouldn't have wanted to go through and do that 25 times to find that value. That's a whole lot quicker using the formula. So same thing, number 6. Again, I'd go ahead, pause the video, try it out, and then come back and see if you match up. So here we go. We're looking n equals 100. So a sub 100 is what we're looking for. A sub 1 plus 100 minus 1 times our d, which is 7. So that's 92 plus 99 times 7, aka 693. And so that means our 100th term in this sequence would be 785. Now number 7 looks a little different. It says find a sub 12 if a sub n equals 8 minus 5n. So let's still just plug things in. They just straight out gave us a formula, 8n equals 8 minus 5n. So it's not even as complicated as using the formula we did in 5 and 6. So let's just plug in. So a sub 12 equals 8 minus 5 times 12. Sometimes we'll luck out and they'll just give us a formula to figure it out. So 8 minus 60, aka a 12, or our 12th term, is -52. Alrighty. So let's do some more with actually solving out for our different pieces. So here we go. Number 8. Find a sub 7 if we know that our sequence starts with 3, 10, 17. So let's think about it from the formula that we were using. So a sub n equals a1 plus n minus 1 times d. What are we missing to be able to fill into that? Well, we know our first term is 3, and then we just need to figure out, well, what's that common difference? And then a sub 7, well, we're looking for the 7th term, so that's going to be our n value. How do we get from 3 to 10? And again, if we're on an arithmetic sequence, that means we're only going to add or subtract. So we would have to add 7. Does that work for the next term? Yeah, 10 plus 7 would give us 17. So there we go. There's our info. D equals 7, and we're looking for the 7th term. So a sub 7 equals our first term, 3, plus 7 minus 1 times 7. So 3 plus 6 times 7, otherwise known as a 42, and 3 plus 42 is going to give us 45. Okay, next one, number 9, find the 20th term. And it looks kind of weird with fractions, but again, you can just subtract the fractions. We're going to have another value. Now, I'm using a TI calculator off to the side to do this. If you're using a Desmos calculator, again, if you type it in fraction form, it's probably going to yield fraction form. But you could also, if you need to convert it, look for a little fraction symbol over on the left-hand side. So if it gives you a decimal answer, click that little fraction button and it'll turn it back into a fraction for you, which might be a little easier to understand what's going on with this. But if I go ahead and subtract, if I do 1/3 minus 1/2, I actually get that I have to subtract 1/6. And same thing, 1/6 minus 1/3, well, my difference is a -1/6. And I know that this is going to have to be a negative common difference because my values are actually getting smaller. Because again, the bigger the number in the denominator, the smaller the value of that fraction. So again, 20th term means I know n equals 20. I know my common difference, and I know my first term is 1/2. So a sub 20 is my first term, 1/2, plus 20 minus 1 times a -1/6. So again, 20 minus 1 gives me a positive 19 and -1/6. But if we're multiplying fractions and I can turn this into a fraction, again, we're just multiplying straight across. So this is really 1/2 see, positive 19 times negative 1/6 really means negative, and then 19 over 6. And if I wanted to do this brute force, I need to turn my 1/2 into a fraction with a denominator of 6. So that's really 3/6 minus 19/6, and that all comes out to a negative 8/3 when I simplify that down. If you did this with decimals, you should be getting out a negative 2.6 repeating. Alrighty, so some application problems. So let me actually change my color. So one of the things that you may be asked to do is if you're stated, or if you have some values for an arithmetic sequence and then we have missing values, well, how are we going to find the extra values that are kind of stuck in the middle of that? And so these are these types of problems that we have for 10 and 11. So technically, when we're doing this, we're finding something called the arithmetic means. And you've heard the word means before, and actually I just realized I had 2 spaces on there for you to use, but that's okay. So when you find the mean of 2 numbers, what's that another term for? Well, it's kind of like finding an average. When you find the average of 2 numbers, you're looking for the middle terms. And so when we say arithmetic means, it's kind of like we're finding the middle numbers, which is why it's means plural, of this sequence. And so again, we just have to figure out how this got kind of divvied up with what difference we had in between the steps. So that's what I do, I count. So I had, starting from 144, I had 1, 2, 3, I had 4 steps. So I need to know what's the difference between 44 and 92, divide that up into 4 steps, and that'll tell me how much each step should have changed. So 92 minus 44, that's going to give me a 48. And so 48 divided up into 4 steps, well, that's going to give me a 12, and it's a positive 12. As long as I do the top number, the last number, minus the first number, then it's also going to kind of help me out with what the sign is on that common difference. Although I can tell just from looking at the sequence, going from 44 up to 92, I'm going to have to add values at each step. So we're just going to add 12 to each term to get to the next one. So 44 plus 12, well, that's going to give us 56. 56 plus 12, that'll give us 68. 68 plus 12, that'll give us 80. And just to double check, 80 plus 12 gets us to 92. We perfectly divided up that sequence. Alrighty, same thing, number 11. This one's a little different because different number of steps. So from 16 up 1, 2, 3, 4, 5 steps. So next, find the difference. So 91 minus 16, again, we're going to have a positive common difference because we have to increase to get to the next stage. 91 minus 16 is going to give me 75. And so 75 divided by the 5 steps I need to take is going to give me 15. And so I'm actually adding 15 to each value to get to the next in the sequence. So 16 plus 15 gives me 31, plus another 15 gives me 46, plus another 15 gives me a 61, plus another 15, 76.